In this lesson, we're going to learn about squares. So remember where squares are located on your flow chart. They're at the very bottom of the chart, meaning they inherit all of the other characteristics or properties from the other quadrilaterals on the chart. So when we talk about squares, we can say a square is really a quadrilateral that is also a rectangle and a rhombus. It's also a kite. It's where everything merges together. So it's when a rectangle and a rhombus really come together. So you have the four congruent sides from a rhombus with the four congruent right angles, and that's how you're going to get your square. So it has all of those properties, even the properties that aren't listed here. So even the properties of a parallelogram, isosceles trapezoid, all of those things flow into a square. So if we look at this example here, we have a square ABCD. So let's go ahead and draw this. And we have AB is 2x minus 14. BC is x plus 15. We want to find the value of x and the length of a diagonal of a square. So first of all, since this is a square, we know that all four sides have to be equal. So all four sides are congruent. Also, because a square is a rectangle, it's going to have four right angles. So that's the most basic idea of a square. The most basic definition of a square is it's a quadrilateral with four congruent sides and four congruent angles. So it's kind of combining the properties of a rhombus and a rectangle. So looking at this, if I know I want to find the length of a diagonal, I also know that the diagonals are equal in a square because a rectangle has congruent diagonals, so they flow down into a square. So I'm going to just make a note of that. The diagonals are congruent. So what that means is if I can find the length of one diagonal, I'll be able to find the length of the other. So if I sketch in this diagonal, I'm looking at this right away and thinking, okay, well, that's a right triangle. So if I could find x, I could plug it back in, and then I could use Pythagorean theorem to find the length of the diagonal. Now, if I've done it if I've drawn in diagonal BD, that would be fine. And I just know that AC and BD are equal. So it doesn't really matter which diagonal you find, is what I'm trying to get at. So let's go ahead and find x. So to find x, since all four sides are equal, these two values, or these two expressions have to be set equal. So 2x minus 14 equals x plus 15. So we're going to subtract x from both sides, add the 14 to both sides. So we end up with x equals 29. So there's our value of x. What we want to do now is plug that back in. So plug it in to each. I would plug it into each just to check. So I have 2 times 29 minus 14. So again, 44. So then if I want to find the length of this diagonal here, I'm just going to call it C. And I'm going to use Pythagorean theorem. So this is step 1. Step 2 is going to be to do Pythagorean theorem. So I have a squared plus b squared equals c squared. So I have 44 squared plus 44 squared equals c squared. So I'm just going to go ahead and combine those. 44 squared plus 44 squared is going to give me 3,872. And we want to square root this. So what I'm going to do is go ahead and, so 44 squared was 1936. Since I had two of those, I know that this number here has to be divisible by 44 squared. So when I go to break this down, I know that the largest perfect square in it is actually 44 squared. So 3872 divided by the 44 squared is going to give me 2. There's 2 of them in there. So the 44 squared is the 1936. And then there's 2. So again, I knew you could have just guessed and checked until you find the largest perfect square. But I just knew since I have 2 44 squareds to get the 3872, 2 times 44 squared is going to give me that number. So that's kind of just a shortcut that I used. So then I end up with 44 square root of 2 for C. And that's my diagonal. So let me just write equals the diagonal. And that, again, would be the same for BD as it is for AC because the diagonals are congruent. So looking at the next question, find the length of the side of a square whose diagonals are 12 centimeters. And remember, in a square, the diagonals are congruent. That's why it's just one diagonal is listed here because they're equal. So again, if this is my diagonal that I'm choosing to use, that's 12 centimeters. I want to find the length of a square of the side of the square. And since we have congruent sides, all four congruent sides, I'm just calling this x and I'm calling this x. I also know I have a right angle because we're dealing with a square. So again, you have a right triangle being used. So I can use Pythagorean theorem, or you can even go back and think, the trig unit if you want for these. So I have x squared plus x squared equals 12 squared. So this is going to combine. There's two of those, so it's going to be 2x squared equals 144. You're going to divide both sides by 2, so I get x squared equals 72. Square root both sides, break this up. So the largest perfect square that's going to go into that is going to be 36. So 36 times 2 is going to give me 72. So break that up into 6 root 2. So one of the sides of this square would have to be 6 root 2. And then this last example is pretty much the same idea. So you're finding the length of a side of a square whose diagonals are 16 centimeters. So here's my square. All four sides are equal. Again, I have all right angles. Let me go ahead and I'm going to draw the diagonal in the other way just to show you that you can. So I could look at this diagonal. That's 16. And I know that these are x and x, so it could be exactly, again, the same process. X squared plus x squared equals 16 squared. And then I have 2x squared equals 16 squared. So 256. Divide that by 2. I get x squared equals 128. And then find your largest perfect square that's going to go into 128. So that's going to be 64. 64 times 2. So I get 8 root 2. So again, that's one of the side lengths. Now, for these, keep in mind too, I don't have to just look at one diagonal. Another option for this page would have been to take my square, and I could have drawn in both diagonals. And I know that those are perpendicular. So if this entire thing is 16, I could have said 8 and 8, and really, because a square is a rectangle, all four of these little parts are equal. So that would have meant that this is 8 and this is 8. So I could have done the setup a little bit differently. I could have said 8 squared plus 8 squared equals x squared. So using just one of these small right triangles. And again, I'm kind of combining the properties of a rhombus, all four sides being congruent, perpendicular diagonals, as well as the properties of a square, congruent diagonals, four right angles. I'm actually really not using the four right angles here because this is my right angle, but you're using the property of the congruent diagonals, the four congruent parts there. So then when you go to combine this, we have 64 plus 64 equals x squared. So we end up with 128 equals x squared, and hopefully you're seeing the similarity right here between these two. So this ends up being square root of 64 times the square root of 2. So we get 8 root 2 again for the side. So see how the setup looks completely different, the picture, but in the end you get the same answer because for both of these pictures, I'm still using properties of squares. So the nice thing about squares is because they have so many properties, sometimes there's more than one method that you could use to solve one of these problems. So just kind of keep that in mind. So go ahead and on the next page, get some key ideas written down and then do your check your understanding problems, and then we'll come back, we'll talk about those in class, and we'll also look at some proofs that are using squares as well.